A dead laptop keyboard stops you right in your tracks. Before you start prying off keycaps or buying replacement parts, our first step is to prove exactly where the fault lies. Is the physical machine actually broken, or is the operating system just confused? To test this, plug an external USB keyboard directly into the laptop. If you can type normally, you know the operating system is still actively processing inputs. Now we need to test the laptop's built-in keyboard by entering the BIOS, or UEFI. The BIOS is the basic input-output system, a pre-boot environment that operates entirely outside of Windows. Restart your computer. The second the screen lights up, repeatedly tap the designated startup key, usually F2, Escape, or Delete. This diagram shows our diagnostic path. If you can use your arrow keys to navigate the BIOS menus, your physical keyboard and motherboard connection are functional. Because the hardware works here, the problem must exist in the software domain. By confirming the hardware is intact, you save yourself the trouble of disassembling the laptop, and you know exactly where to focus your repair efforts. If your keyboard works in the BIOS but dies in Windows, you are likely dealing with a corrupted driver state. Windows 11 has a feature called Fast Startup that often traps hardware in these processing loops. This animation shows how Fast Startup operates. Instead of fully shutting down, the system saves a snapshot of your loaded drivers into a hibernation file, known as hyberfill.sys, and reloads that exact state when you boot back up. If that saved driver is crashing, restarting the normal way just reloads the crash. To force a full initialization, go to your control panel, open Power Options, and turn off Fast Startup. If the driver is healthy, the operating system might be intentionally ignoring you. Windows includes accessibility features like filter keys, designed to deliberately block brief or repeated keystrokes. Open your Windows settings, navigate to Accessibility, and select the Keyboard menu. Check the toggles for both filter keys and sticky keys, and turn them completely off. When settings adjustments fail, right-click the Start button and open Device Manager. Expand the Keyboard section, right-click your laptop's keyboard, and select Uninstall Device. Once the uninstall completes, you must restart your computer immediately. This forces Windows to discover the hardware as if it were brand new and build a fresh, uncorrupted driver. By flushing out the hibernation files and resetting the input filters, the operating system reestablishes a clean line of communication with your keyboard. Now, let's look at the physical side. If your keys have lost their tactile click or feel mushy when you press them, there is likely physical debris blocking the mechanism underneath the keycap. Start with gravity, power the laptop off, unplug it, and hold it upside down at a 45 to 75 degree angle. Give the chassis a few gentle taps to dislodge any loose crumbs. This video demonstrates the next step, using compressed air to clear the matrix. You must keep the canister perfectly upright at all times. Warning tone: if you tilt the air canister sideways, it will spray freezing liquid propellant. That extreme cold can shatter the delicate plastic membranes inside the switches or create condensation that causes an electrical short. For sticky, localized spills, switch to a chemical approach. Lightly dampen a cotton swab with 70% or higher isopropyl alcohol and trace the edges of the sticking keys. Do not oversaturate the swab. If excess alcohol drips beneath the key mechanism, it can trap residue deeper inside or create new electrical shorts across the board. Removing these physical barriers allows the key to fully depress, closing the circuit required to register your keystroke. Sometimes an entire section of the keyboard goes dead at once. This points to the physical connection inside the machine, a flat ribbon cable held by a zero insertion force, or ZIF, connector. This fragile bridge can slowly wiggle loose from thermal expansion or a sudden drop. Before you inspect this connection, you have to open the laptop's bottom chassis and immediately disconnect the internal battery. Do not touch the ribbon cable while power is flowing through the system. This illustration shows the internal connection. Use a non-conductive plastic tool to gently flip up this locking latch on the ZIF connector so you can slide the ribbon cable out safely. To reseat it, slide the cable back into the slot. Look for a painted alignment line on the ribbon itself. That line must sit perfectly parallel to the connector housing before you press the latch back down to lock it. If the plastic clip snaps off entirely, you can apply an engineering workaround. Wedge a thin plastic shim or a tiny piece of electrical tape behind the cable. This creates artificial pressure, forcing the cable's contacts tightly against the pins. Every single pin must make a flush, unbroken connection with the motherboard to translate your mechanical keystrokes into data. A liquid spill is an immediate hardware emergency. Water conducts electricity, and every passing second the laptop remains on allows the liquid to bridge circuits and corrode the motherboard. This video demonstrates the exact action you must take. Do not try to shut down normally. Press and hold the power button for 5 to 10 seconds until the machine goes completely black. Next, unplug the charger and any external devices. Open the laptop as wide as it will go and flip it upside down into a tent position over a dry towel so gravity can pull the liquid away from the internal components. Firmly do not reach for a hairdryer or a bag of rice. The heat from a hairdryer will melt the plastic keyboard membranes, and rice introduces conductive starch dust directly into your cooling vents. Leave the laptop resting in that tented position in a dry, well-ventilated room. You must wait a minimum of 48 to 72 hours before you even think about pressing the power button again. By cutting the electrical flow instantly and allowing the internal moisture to fully evaporate, you give your machine the highest possible chance of surviving the spill.